Now that you've learned what plate tectonics are and how they move, we're going to look at the different plate boundaries and the crustal features created at these plate boundaries. We consider plate boundaries to be anywhere that the different plate tectonics meet each other. In the picture below, which you don't have to draw, all of the bold lines represent plate boundaries, and there's three types: divergent, convergent, and transform boundaries. The first type of boundary is called a divergent plate boundary. Make sure you draw the diagram at the bottom so you have a visual of the motion happening at a divergent boundary. The plates pull away from each other. The scientific term we use for that is tension. The crustal features created at divergent boundaries include oceanic ridges, rift valleys or continental rifts, and seafloor spreading. Real-world examples would be the Mid-Atlantic Ridge, which is located at two oceanic plates that are pulling away from each other, and the East African Rift Valley or Great Rift Valley, which is located at two continental plates that are pulling away from each other. Here's a simple diagram of what it would look like at a divergent plate boundary. As you know, there is magma in the mantle, and convection currents are the driving force that pushes magma up through cracks in the crust. When that magma cools, it pushes the already existing plates away from each other, thus creating a divergent plate boundary. The second type of boundary is called a convergent plate boundary. Make note of the diagram in the top right corner so you have a visual representation of the motion happening at this boundary. The plates are moving toward each other or colliding. The scientific term we use for that is compression. Something important to remember is that the density of the plates interacting is what determines what happens at a convergent boundary. There are three different types of convergent plate boundaries: ocean to ocean, continental to ocean, and continental to continental. My suggestion is that you pause the video to get this information written down. A thing to remember is that density is the determining factor for a convergent boundary. So the more dense of the two plates will sink or subduct underneath the other plate, and that subduction results in a variety of crustal features depending on the type of plates you have interacting. Here we have an ocean-to-ocean convergent boundary. What happens is that the older, more dense oceanic crust will push under and subduct underneath the younger, less dense oceanic crust. That subduction will push up the magma, which leads to the creation of volcanic islands. Our real-world example would be the Aleutian Islands, which is right on the coast of Alaska. Here's our visual for an oceanic continental convergent boundary, where the more dense oceanic crust will subduct underneath the continental crust. Once again, the magma gets pushed up and we get the creation of coastal volcanic mountains. The example, or real-world example, being the Andes Mountains in South America. Here's the visual for the continental-continental convergent boundary. Since continental crust is less dense, whenever they collide, you get the breaking and folding of the crust, resulting in mountain ranges, the most well-known being the Himalayas, where the Indian plate collided with the Eurasia plate. The third type of boundary is called a transform plate boundary. Make sure you get the diagram drawn at the bottom so you have a visual representation of the motion, which is that plates slip and slide past each other in opposite directions. The term we use for this is shear. The crustal feature created at transform plate boundaries is faults. Unlike divergent and convergent boundaries, there is no production or destruction of the lithosphere. The real-world example for a transform boundary would be the San Andreas Fault, where the Pacific plate and North American plate slide past each other, as you can see in the middle picture. Now with this motion comes earthquakes, which you can see in the left picture. The right picture is a real-world picture of the San Andreas Fault. Now, earthquakes can occur at any plate boundaries, but they're most often associated with transform plate boundaries. So there you have it. Divergent, convergent, and transform plate boundaries. Not only should you know the motion associated with these boundaries, but you should know the features created and some real-world examples.